Hi, good morning, good afternoon, good evening. This is Kaushik Ghosh, Director of Product Management at Dell Technologies. And today we are talking about PowerScale, our next generation scale-out file storage. Scale-out file storage, PowerScale, there are three pillars that are for this storage: simplicity at any scale, any data anywhere, and intelligent insights. In this section, I'll talk about any data anywhere. What do we mean by it? What it is all about, and go from there. So one of the things about PowerScale with this particular release is that we have now unlocked the operating system, the file system, from custom hardware. So we can now run PowerScale OneFS on your existing Isilon nodes. You could also run it on PowerScale nodes, which are based on PowerEdge-based servers. There are two servers there and expanding to other servers, and you can run it in the cloud as an example. So you get the same rich experience of PowerScale, the same rich data features and capabilities now at your core data center, at the edge, at the cloud, and be able to replicate the data from these different locations using PowerScale's native replication capabilities.
Kaushik, you mentioned that you could run it in the cloud. I mean, are you talking about deploying it across AWS, EC2, EBS volume kinds of things, or is that a special solution that runs in the cloud, or is it a near cloud solution, or what?
Great question. So in fact, I have I have slides which will go into more detail, but at a very high level, it is offered as a service. It is a cloud-like service, which is tightly integrated with Google Cloud in our example, or a solution which you can use with any of the hyperscalers like Azure, AWS, and so on. Right? We'll talk a little bit more about it. It is a service, so it's not just like a VM and you run it and manage it on your own type of thing. This is a full-scale production solution.
Okay, thanks.
All right. So we talked a little bit about the different workloads, unstructured workloads, whether it's sensor data, whether it's home directories, whether it's video editing, genomics, and so on. As you can see, these workloads typically require a lot of burst processing. So it's ideal to basically move it into the cloud for a particular job, leverage the agility of the cloud compute, do the processing, and when the job is done, you don't need the compute. You don't have to use it. Your data comes back and stays or is staying on your on-prem. Likewise, you have sensor data, which is being generated at the edge. You do some quick processing at the edge, and then you send it back to the data center. So this type of data needs to be at the edge, at the core, at the cloud. So we have PowerScale and Isilon. You know about it. You have it at the core. As we talked about it, PowerScale OneFS is now unlocked. We have and you could run it on servers. Today we have two servers that we have qualified, our 640 servers, PowerEdge-based servers. In future, we'll be adding more servers to that hardware compatibility list. We'll talk a little bit about the use cases the software-defined brings in the next slide.
Are we likely to see non-Dell servers be certified, or is this can be restricted to just run on Dell hardware?
So initially, right now, of course, we have PowerEdge servers. We believe we have the best servers. So of course, we started with that, but we are looking to see if there are requirements for other servers. We can definitely look into that. So it's mostly a business call that we have to make. So moving forward, so the other thing that we also offer is basically making PowerScale OneFS available in the cloud. We'll talk a little bit about it. It is a full-fledged solution. It's a as-a-service type of solution. So basically, you sign up and ask for the capacity, and then you pay on a monthly basis, right? So you don't have to manage the storage. You don't have to worry about code upgrades. You don't have to do disk replacements or anything like that. We take care of it. It's a full service. You just set up your applications, spin up the compute, mount the storage, and use it.
Right? So just to be clear, on the cloud, options here. You mentioned GCP had a Isilon service, and then AWS and Microsoft Azure can connect to Isilon services, but they're not necessarily an AWS or Azure marketplace service. Is that true?
That is correct. So we have two services we'll talk about. So one we call the multi-cloud service. The multi-cloud service allows you to connect to any of the hyperscalers.
And it's a near cloud environment kind of thing,
That is
right?
correct. That is correct. And then we have the native cloud service, which is more tightly integrated with Google Cloud.
Okay. Thank you.
Yeah. Yep.
Sorry.
Yes.
Just one more detail. So the GCP option is a virtual option or a physical option?
It is a service at the end of it. So you'll basically go.
But is it based on a? So the difference is that if it's a physical option and I want to use my storage for like 5 hours to run a job and then delete everything, maybe I have to pay for 1 month. If it's a virtual option, maybe I can choose to pay only by the minute or by the hour, because I just want to run a big data analytics thing, and then like FSX for Lustre in AWS, for example. Okay, so it's becoming more and more common to have this ephemeral-like file systems that I use for just the time I need to run my job. Okay, so I can import my data, replicate my data from an environment, and stop it. For example, all the entire infrastructure when I don't use it, so I don't pay for the resources, just for the storage. You know what I mean?
That is correct. So at the end of it is basically there is servers sitting out there and our software running on it, right? So what you're saying, and like we talked about it, Callan talked about it, our PowerScale file system can grow dynamically and it can shrink dynamically. So for example, if you're a customer and you say, look, I want 100 terabyte of data for 3 days, as an example, right? So we can spin up a cluster with 100 terabyte, right? Whether it's physical, at the end of it, there is still servers sitting behind it, right? You have to replicate the data to this instance. You use it for the number of days you want it with your compute. And then if you don't need 100 terabyte, you want to shrink it down to 10 terabyte, you can do it, right? So the technology allows you to do that. Now, from a business perspective, would I go through the pain of supporting it for 3 days, customer coming in?
No, this is why I asked if it is virtual or physical, because if it's virtual, like FSX, like, many others now, you can, with a cloud formation script or whatever, you can spin up your configuration. You can do whatever you need. You pay by the hour, and then that's it. Of course, if you have servers, that you have to buy and manage and everything, it's unfeasible. So the question is it a virtual on GCP or is it a physical anyway?
Okay, so let me answer. So it is not running on GCP's infrastructure, if that's what your question is. It is not running on GCP's infrastructure. It is running on our infrastructure, but it is...
There is no way I can pay by the hour or by the minute and shrink my capacity from...
That's what I was saying, is that because you are buying it from the experiences, and I'll talk about it in detail. The experiences, basically, you go to the Google Clouds portal, you basically just like you sign up for the compute, you sign up for the storage, right? And you specify how much capacity you need, and we will basically get that storage set up for you, right? For that amount of capacity. And this is all automatically done. So there is no human intervention or anything like that. We'll set it up for you. You get that capacity, it's managed, it's through your Google Cloud portal. You see all that storage, you mount it to your compute and you use it there.
How are you leveraging the egress then?
There is no egress charges because it is our near cloud data center is considered an extension of Google's data center, right? So the linkage between our near cloud data center and the Google Cloud is a private connection. So there is no egress charges involved.
And how much time does it take to configure the cluster to get my storage up and running?
I mean, there is a business piece of it, whatever time it takes. But the setting up of the cluster, like we talked about, Callan talked about it, every time you add a node, it takes less than 60 seconds to add a node. So if you want to expand.
But if I order on GCP now, is it 60 seconds or?
No, there is a little bit of time because it has to be set up. There's a business process that has to go through. So it takes, I think, a day or so to set it up for you. But once it's set up, the expansion is really easy.
Who's running the near side? The near.
Dell EMC is the service provider, so we take care of it. It's a cloud experience for the end customer.
So you guys don't use partners to do that? It's actually y'all?
Depends. So the multi-cloud service is through a partner. The Google Cloud service is through us directly. So that's that. And we'll definitely talk more about it in the next few slides. And then, like we talked about our PowerScale, our entry PowerScale F200 only has four drives with a 1 terabyte drive. Basically, that's 4 terabytes in a node. Because you can do 3 nodes, we can give you starts at an 11 terabyte, a really attractive price point as well as capacity point and performance that it gives you for a remote office and edge deployment and so on. Where for example, and this picture is showing, you could store sensor streaming data, do some quick processing, and then send it back, send it into the core for longer term storage. So this shows you about the full family today. So like we said, the PowerScale OneFS supports our existing Isilon nodes. The Isilon nodes are archive nodes, hybrid nodes, and there is a flash configuration also available. And then the PowerScale server-based nodes basically are all flash, all NVMe nodes, and you can run the same PowerScale OneFS and all these nodes. You can put it into one cluster, separate clusters. It's entirely up to you how you want to set it up. Looking a little bit in detail behind these PowerScale servers. So they're both based on Dell PowerEdge servers. The PowerScale F600 includes NVMe drives. It has 100 gig front-end connectivity, 100 gig back-end connectivity, and has 8 drives per node. So if you look at three node is the minimum for a cluster. You can the starting capacity is at 46 terabyte. Now, if you take the larger drives, you can go up to 184 and even larger, right? And that's just the entry starting capacity. You can scale, like as I said before, to up to 252 nodes and petabytes of capacity. And then our PowerScale F200 is our all-flash systems, entry systems with 25 gig connectivity. It has 4 drives per node. And again, if you take the smallest drive, that's 11 terabyte minimum. And then similarly scaling up to 252 nodes and petabytes of capacity. If you look at our F200, our entry system, compare it to our previous entry system, which was a hybrid system, we're getting almost like a 5x performance gain for the same capacity and with data reduction built in at almost the same price point, the same capacity, but with almost a 5x performance gain.
Kaushik, so could you give us some numbers for the new performance? There was a question on Twitter about that as well.
From a performance perspective, I think what we are saying for the F200, you can get up to sequential reads, get up to 2.5, 2.7 gigabytes per second. From an F600 perspective, if you look at it, compare it to our previous hybrid platform, the generation hybrid platform H600, again, with the data efficiency built in, you can, and the larger drives, we see almost a 50% drop in operational cost comparing the two platforms. And then inline data reduction is built into both of these platforms. Depending on the workload, your data reduction varies. Now, I'll put a statement out here. Unlike in a primary storage, primary market space, the workloads in an unstructured environment, the data efficiency of the unstructured workload varies greatly. So if you are in an IT environment with file shares, home directory, you will typically get a lot of data efficiency. On the other hand, if it's a high performance production workload, like a video files, like genomics or whatever, right? There, typically, we don't see a lot of data reduction. So depending on the use case, if it's an IT production type of use case, home directories, you see a lot of data reduction. HPC production workloads, probably not as much data reduction.
Are you able to mix nodes? So could you start with a F200 and then realize that you're scaling up bigger and add a F600, or start with 3 F200s and then add a F600 from there, or would you have matching nodes?
Absolutely, that's one of the value propositions of PowerScale OneFS, that you can mix and match nodes. Not only F200s and F600s, you could even decide like, hey, I have a lot of data that I don't need high performance. Let me put in some H5600 or some of the hybrid nodes or some of the archive nodes into this cluster, and they're all part of the same file system. So it's not like you have to manually move things around. We'll auto balance it, we'll distribute it across these tiers and so on. A very high level positioning between the two nodes. So if you're trying to decide, should I buy that F600, should I buy the F200? Our F600s are NVMe based on NVMe flash drives. They are our lowest dollar per gigabyte solution from an all flash perspective. And like we said, it offers 100 gig front end, back end connectivity. And it's a really good solution. While you can definitely you buy an F600 for smaller capacities, we start at 46 terabyte. It's a really good solution when it's above 180 terabyte or so. It's a really ideally suited for that scale. F200, on the other hand, is going after that entry, the mid-range space. We offer the lowest entry price out there for that 11 terabyte configuration, very attractive. It offers the lowest dollar per throughput. If performance is important and price is important, both of them, then that offers the lowest dollar per throughput. Because it has a 25 gig connectivity, it can downgrade to a 10 gig. So if you have 10 gig switches, it can work with it. So it has the most compatibility when it comes to existing.
Kaushik,
Yes.
Do you guys see a lot of homogeneous clusters out there with the same node types, or are they more mixed, or because I mean, you've got 100 gig support required for the F600, you got 25 gig support required for the F200. I suppose they could all be on the same 100 gig network, but the performance advantage of maybe a mixed configuration, is that some sort of a mix between the two, or is the lowest common denominator? I'm just trying to figure out what a mixed configuration performs like.
Yeah, no, absolutely. So today, of course, the PowerScale, we launched it only last week. So we don't have a F600 and F200 in the same cluster. But if you look back in our Isilon, I mean, we do have customers leveraging all flash, which give you great performance, and we have the archives, which don't offer, which is basically for cold storage, being mixed as part of the same cluster. So yes, absolutely. Absolutely possible. Customers do understand that these nodes are going to give you the better performance, the other nodes are not. In fact, we have this concept of tiers, so you can when you add an archive node to the cluster, you will designate it as a cold tier, right? So when PowerScale knows that these are cold tiers, you will only move it based on the policy that you set it up.
So the auto balancing and all that is on a tier level kind of basis. Is that how it would work?
That is correct.
I got you.
So we do the auto balancing at a tier level, and then you can set up policies to say, hey, if this data is not being used for a long time, whatever your policy is, move these data to the lower tier or to the cloud, then we can do that as well.
Sorry, do you also have benchmark figures for all these new nodes? And
from a performance perspective?
Yeah.
Yes, we do have it. We have it published. We have white papers, performance white papers. We have application-specific white papers as well for these nodes. Yes.
Okay.
And can I just jump in and just say, just to make it clear, so that the only minimum requirement we have for networking is on the back end, but each one of these has varying different options on the front end. So you could still have, just back to, I think it was Ray's question, you could still have 10 gig connections coming into an F600 if you wanted to. But It just comes down to, what the customer needs. But again, the only minimum is on the back end. And that's to make sure we can get the performance out of the actual underlying nodes themselves from a file system perspective.
Thanks, Callan. Thanks for that clarification. Okay, so let's talk a little bit about software defined, because one of the big things that we have introduced with PowerScale OneFS is this unlocking of the software and the hardware. So today we support the two PowerEdge servers, the R640 PowerEdge servers that we support today. We support Ansible playbooks, so it gives you automation, workflow automation. We support Kubernetes and OpenShift containers, and we'll be adding more plugins, DevOps, automation, and so on with this solution. One of the things that we are working on, which is coming very shortly, is this part of the next journey of our software defined, is to be able to rapidly deploy an operating our PowerScale OneFS on a system from scratch. So what's the use case for it? So the use case is this: the whole premise on software defined is customers are trying to build their own cloud in-house, right? So they will buy a bunch of, say, PowerEdge servers, and then they will redeploy it for, depending on their need, deploy it as block, deploy it as file, deploy it as object, use it for a certain number of days. When they're done, they scratch it off, and they will go and redeploy it for whatever the next workload is, right? In order to be able to do it, you can't just get a system that comes from the factory and that stays with it, right? Or every time you have to reinstall it, someone has to show up with a USB stick and do it. It has to be all automated. You'll be sitting in your home, press a button, the server gets configured completely from scratch with a new PowerScale OneFS deployment, right? So that's basically where we are headed. So we now run it today. We unlocked it. The next stage is basically now, can you press a button and push that entire installation automatically and destroy it and then reset it up again with a different operating system or the same operating system, whatever. Right, so that's basically what's coming soon. And then, like we said, today we only support 2 servers. We are going to expand that our hardware compatibility list to include our PowerEdge servers, and if there is a business case, potentially other servers as well. So why we are going with this route? So first of all, it is because some of our biggest customers are headed that way. Like we talked about it earlier, customers want to buy one set of hardware and use it for their different workloads. So buy a PowerEdge server, like I said, use it for file, use it for object, use it for block, depending on the demand, depending on the use case, and so on. It also offers use case flexibility. So one customer may have a certain memory requirement, the other customer may have a different memory requirement, slightly different thing. If it's a purpose-built appliance, as you know, our memory is fixed, or everything is fixed. With a server, now you can, as long as you have the minimum, you can now play around with it. Hey, I need a little bit more memory and a little bit more drives. I want to use a different front end than the standard, right? So it gives you a lot more flexibility in how you build up this server. And then lastly, it allows us to sort of leverage the hardware acceleration, the hardware innovation that PowerEdge brings to the table. For example, as you saw, we now have 100 gig support, NVMe support, because PowerEdge, typically the server roadmaps are typically ahead of the purpose-built appliance roadmap. So by leveraging the PowerEdge roadmap, we now leverage that innovation that PowerEdge brings to the table.
Hey, Kaushik, will you go back a slide real quick for me, please?
Sure.
I'm sorry.
Absolutely. No problem.
You were on a roll. I didn't want to interrupt you.
No,
okay, so for this one, the only thing that's available now is that first box with the Ansible playbooks and Kubernetes OpenShift containers.
That is correct.
And all this is something it's some containers that are embedded in the file system that I can deploy, and it sets it up, or how does this actually work?
The second one, the one in the middle?
No, the first one.
The first one. No, the first one. All it says is basically basically part of the software defined is not just unlocking the software from the hardware. There's a lot of automation is also part of the equation, right? So today we offer Ansible playbooks. So with these playbooks, you can do a bunch of automated tasks, but that's only after the initial operating system is set up. Once the operating system is set up, you can now go through Ansible and you say, hey, I want to create a directory. I want to set up some quotas. You can automate all of those tasks, right? But the initial installation still is manual. And what we are saying in this roadmap, the second part is that initial installation, we are automating that as well. So once you have that and you combine it with the Ansible playbooks, then you have a end-to-end automation. You automate the setup, then you automate the configuration, you configure it the way you want it, right?
Right. So are these the Ansible playbooks and the OpenShift containers, are they the ones that are on, these are available publicly?
Yes. So these are plugins that we offer. So these plugins basically integrate with your existing Ansible environment. And then you can use that environment to manage the PowerScale cluster.
All right. And the timeline here is the idea is that it will be just automated, that you can just pull them in like you would normally with I'm going to say something old. So like you would just pull them in automatically into the file system by running a command and be able to deploy. I was going to say curl. I don't know if that's still the thing.
No, so the plugins part of it is there today. So with the plugins, you can automate the directory creations and quotas, managing the quotas and all of that. So that's all available today. The part which is missing is installing the file system, the base file system on the server, right? So the base operating system, that's the part which we are looking to automate in that second part. Right. So when you get a server which is completely bare bones, nothing installed, how do you get that operating system installed and up and running?
Gotcha.
So, and once you do that, then that completes the full picture. So earlier there was this question around, hey, in a Google Cloud, once I go to the marketplace and I say, hey, I want to get this up and running, how long does it take me? Right. It takes me a day because there is a person has to go and set up the server. Once I have this automated thing, then you press a button, it pushes it down, and the operating system is basically set up on that cluster for you, right? So it vastly reduces the time, vastly reduces that automation. So it not only helps customers on-prem, but it also helps with the cloud model as well.
So, so back to the containers discussion. The access to Kubernetes and OpenShift for Isilon is through like a CSI plugin kind of thing? Is that how this works?
That is correct.
Isilon's not implemented as a container functionality per se, right? I mean, I'm guessing, right? You haven't mentioned anything about that, right? Okay.
That is correct. So Isilon is not based on containers. It supports containers.
Right.
So if you have a container, the reason why we support containers is that, like we talked about it, right? You can deploy the PowerScale OneFS at the edge, at the core, at the cloud. So if you have applications that you not want to spin up in the cloud, putting it in a container makes it much more easy for you to migrate that application across these different locations. Now let's talk a little bit about the cloud part of it. So we talked about how you can deploy PowerScale OneFS at the core. We talked a little bit about software defined, where we are headed with it. Now let's talk a little bit about cloud. So we talked about that for unstructured file type of workloads, cloud is absolutely makes sense, right? For the various reasons I talked about. But if you look into the cloud market, you will see a majority of the use cases there, majority of the usage there is for block or object. So what's going on? If the workload is it absolutely makes sense. It makes sense to use cloud. Why is the adoption of a file in the cloud so low? So our take is basically a couple of these things. One, basically, there is no interoperability, right? So when you move the data, how do you move it, right? How do you move it? How do you move it back? Right, there's challenges out there. Today, if you look at the solutions in the hyperscalers, it doesn't scale, right? Max, you'll probably get a 100 terabyte file system, and that's it. It doesn't scale from a performance perspective. It doesn't scale from a capacity perspective. And cloud is all about scale. So it really doesn't make sense that, hey, you can scale compute, but your storage is stuck to 100 terabytes, as an example. And then the third piece of it is customers don't get the same. Yes, please.
Can I just challenge that comment and say that, bearing in mind that object storage is so ubiquitous in the cloud, perhaps many people just see that as the best route to go for scalability, and they don't bother with the benefits, or don't need the benefits of file locking and other things. So they've just decided object store is better, and they'll not use file.
But my understanding is that is true. If you have an application that is already talking to S3, you could do it. My question is, one, is all your applications talking S3? My understanding is that a lot of applications, like we talked about video editing and so on, that are not talking S3. So how do you deal with those applications? Do you rewrite them just because your storage cannot handle it? And then the second piece of it is again, for that S3 object here in the cloud, what is the performance that you are getting there today, right? So those are two of my comments. But I agree with you. If your applications are all talking S3, if your video editing file talks S3, if your genomics application talks S3, yes, then you don't need file anywhere, and you can go to an S3 model.
Okay, so bearing that in mind, and I don't want to sort of preempt your presentation, but one of the benefits of A, cloud, and B, S3 is the fact that you have the ability to spread that data and make it accessible across multiple regions, and you've got a lot of control and ability to not be dedicated to one region, one location. So I would hope that you're going to tell us that that's what you're going to be offering, is the same level of distributed access to data wherever I place my data, because if I'm cloud native, I don't want to be running in an old style enterprise scenario where it's one data center to another type thing. But I'll let you carry on, and then we'll see how we can measure.
Absolutely. So let's talk about the use cases, because that you bring up a very good point. So let's talk about the use cases. So before we do that, we talked about that we have two solutions today. We have a multi-cloud solution service, and then we have a Google Cloud service. And because they all are based on PowerScale, you can do native replication between those instances to a PowerScale running on-prem on a Isilon or a PowerScale server. So let's first look at the multi-cloud. What use cases it opens up? It's a multi-cloud service, so you can leverage the compute in the cloud. Because there's no egress fees for the replication, because the PowerScale is sitting in a near location, there is no egress. You can use native replication between the two instances, so an ideal use case is a DR use case, right? So instead of having two different sites, you could have one site as the DR site being in the cloud, as an example. So that's one use case. The other use case is basically, hey, I want to do some big data analytics. So I have the data sitting on-prem, but I want to use a few compute for a few days to run it. So I would move the data, replicate the data onto the cloud, and spin up the compute, do my big data analytics. Once the analytics is done, I could either delete the data, or if I need to bring it back, I can bring it back. It's all up to me what you want to do it. Okay. So that's our multi-cloud service. And then our native cloud service offers similar capabilities, but in this case, it is much more tightly integrated with the Google Cloud Portal. So your entire management, your entire user experience is through that Google Cloud's portal. And someone had asked earlier, hey, is there any egress because it's an airline location? No, absolutely, there's no egress. It's a very high performance link between the PowerScale OneFS near data center and the Google Cloud. So from an end user's perspective, you get a seamless experience. And some of the benchmark testing that we have done, Joe's presentation later will cover it. We see about 46x read performance compared to existing file solutions in the hyperscalers, 96x write performance, and the ability to scale up to 50 petabytes all in a single file system versus trying to create multiple buckets of 100 terabyte file systems.